This is Couchbase at Gannett. And sorry. My name is Alon Motro. I'm in charge of the Content Platform Services team. We oversee the publishing systems and a lot of the presentation APIs that power Gannett. And this is my colleague, Chris Alexander. He's the lead on the platform architecture team. He works with various stakeholders within the technology division, and he's really one of our lead software architects. So in case you don't know, Gannett is one of America's largest media companies. We have full national coverage, 93 local and national sites, and we have around 100 million total monthly digital visitors. A lot of people actually don't know it when you say Gannett, but we are the parent company for USA Today, as well as numerous community newspapers such as the Indianapolis Star, Arizona Republic, Des Moines Register, and several others. I would say 93. So for each property that we have, we produce a suite of products and applications. We have desktop sites and a mobile website for each property, and we also have an iOS native application, an Android native application for each property as well. And the content that we produce varies extensively. We have assets ranging from photo galleries to videos to regular text stories. So really we have embeds as well. So we have a lot of content that we need to get out there to the consumers. We also have several APIs available for both internal consumption and for our partners. We have a lot of syndicated content as well with partners like MSN. So in order to support this full range of products, this is our current architecture. I'll go through them one by one. We have like names for everything. So, Presto is our homegrown CMS. It's an editorial tool that allows for the publishing of the different asset types that I mentioned. You can curate content on the front. Curation, as you know, editors can go in and say, we want this story to be number 1, we want this story to be number 3, etc. You can create photo galleries, and several other editorial actions are available through this homegrown solution. The application itself communicates with our internal read-write APIs, which we call AMI or core. It does this by sending AMI a JSON payload for each action that an editor takes. So for example, when they save a draft to a story or they publish a photo gallery, that JSON payload is sent to AMI. AMI then takes that JSON payload, processes it, and it stores it both in our SQL Server databases as well as indexing it in Solr. Now, separately, we have a .NET API framework, which over there is actually also called Core. And that's divided into several different services, including UX and mobile services. UX is our read API for the desktop sites, and mobile is self-explanatory. It's for our mobile apps. These services add fairly complex business logic to the content that's requested for each application. As you can imagine, a desktop site might want a story in a different format than, say, your mobile app. So there's a lot of business logic baked into those services. Finally, we have the search API, and that's essentially a proxy through to our Solr instances. However, it's in existence mainly for content access policy rules that we implement at that layer. So there are several challenges to this architecture that we've encountered over the years. First off, SQL Server costs are pretty enormous. We spend approximately $1 million a year on licensing costs and related costs. With our SQL Server setup, we've had several outages due to replication issues and network-related incidents within our data centers. We've also encountered significant replication latency that's often exceeded an hour within the same data center. And what happens is that, as you can imagine, that causes differing content between the data centers, and that could affect consumers and the content that's available to them. And as I mentioned on the previous slide, there's a lot of business logic, not only in the service layer, but we've also baked that in over the years into the stored procedures, which on its own also causes significant delay between the time an editor publishes a story and the time that it's available to presentation for the consumer. Furthermore, since we utilize mainly on-premises pet servers, it's been very difficult to scale up to accommodate any increased load. And that's not something that's negligible. I mean, in a news organization, those are your most lucrative times, is when there's a big topic of discussion, you know, a hurricane, celebrity news, whatever. Just to give you an example of how kind of ridiculous our setup is, or how ridiculous it's grown, this is, I don't know, it's hard to see, but it's a stored procedure to retrieve an asset or multiple assets from the database. We're talking about 300 lines of code in this one stored procedure. It's a mess. It has many temp tables, a lot of inner joins, lots of variables, and it's complex, and it doesn't need to be. And this is just to see an asset. I mean, our front stored procedure is about the same level of complexity, and we've seen times where it's taken around 20 seconds to get a front from the database flowing through the pipe to the consumer. We have been somewhat protected from this latency through Akamai, and we also have an API management vendor that we use called Mashery that also has a caching layer, but really those just mask the issue, and there's obviously a deep-rooted architecture change that's needed. So, as I mentioned, our architecture was not sustainable, and so we needed to change. We've identified multiple issues, some of which I've already mentioned, and so we went about coming up with a plan, and this was about a year ago. First, all that business logic I mentioned in the stored procedures, that needed to go away. Over the years, as consumers wanted changes, if the native product people wanted some more information for their stories on their iOS devices, we'd have to shoehorn that logic in to accommodate them, and that's, again, not sustainable. We needed to change that. And so part of the way to do this is, as people have mentioned in this conference, is to write as you want to read. So we needed a way to solve the problem where you write as you read, but you also have multiple versions for the different consumers. Due to the replication issues that I mentioned and the difficulty of scaling, we needed to expand to the cloud and have the ability to spin up servers in an instance to be able to handle that load that comes in at some points. And finally, we wanted to lower our costs. Like I mentioned, SQL Server costs are pretty high right now. And we found that, among other things, Couchbase allowed us to operate at about 25% of the original cost of our SQL Server instances. So Couchbase is now an integral part of our architecture, but as I mentioned, we needed to overhaul our entire architecture. So what we did was we split the pipeline into two, basically. One is called authoring, and one is called presentation. First, we tackled the presentation side, which is really, as you can see, the highlighted portion. We added several blocks to our pipeline. I'll actually note, first of all, that you'll see that SQL Server is still in existence at this point, but that'll change in a few slides. So right now, expand it? Sure. Let me see if I can. Oops. Sorry. Oh, well, I need the notes. Yeah, I'm not sure if it's. I'll point them out like this. Yeah, I will. I'll read. So this is, yeah. Right. So this is Presto. So when an editor publishes a story, he's using this tool, it goes through to the core AMI framework that I mentioned earlier. So that's still storing things in SQL Server and Solr. However, we've added this piece here called Cumulo. I will mention that in between AMI and Cumulo, there's a RabbitMQ cluster that we've implemented. So when the story is published, it's sent to that queue. The ID of these stories is sent to that queue, as well as writing to the SQL Server and to Solr. When Cumulo gets that information, it reads the IDs off of the queue, and it, at that point, also gathers any extraneous information it needs to build a full asset. So, for example, if you publish a story, there might be a related photo gallery or related tags. What Cumulo does is it goes back and communicates with Solr and or SQL Server if needed to get that information. Once it's completely formed this full asset, it puts that full asset onto another RabbitMQ cluster that I have not shown here, but it's there. Nimbus is a new Node.js piece that we've implemented. It reads that full asset off of the queue, and then it stores a basic version in Solr. At the same time, it creates additional versions of that asset, one for mobile, one for desktop, and this is where that write as you read ideology is implemented. Also, at this point, we gather in some external data if necessary. So, for example, Facebook share count would be added to that asset. So, and at the end of the pipe, you have the presentation applications. You know, like I mentioned before, the mobile. What used to be mobile services is now a lightweight API that we built. Same thing with desktop. Just to give you a handle of how big our Couchbase dataset is, we have about 5 to 6 documents per asset, and right now we have around 70 million documents in Couchbase, and that grows every day. So as I mentioned, we built a small presentation API and Python and framework on top of the Couchbase implementation, which allows us to retrieve the assets in any format at any time. And I have this slide up here just to show you the difference between that stored procedure you saw earlier and how we can get an asset now. As you can see, it's ridiculously easy. It's in Python. It can be in pretty much any language that Couchbase has a library for. You pass in the IDs of the assets you want, the type that you want, mobile, desktop, things like that, or maybe a light version, and you get it back all with one multi-get. So back to the architecture, the second portion that we started to implement was called authoring. I'll point out the pieces again. So you still have Presto here, but instead of that core AMI process that I talked about earlier, you have something called Geronimo. That's new. It is a Node.js application. It's an event-driven CQRS architecture. It's designed to support all the author activities I mentioned earlier: publishing, saving a draft, deleting a story, etc. With CQRS and event-driven architecture, you have versioning pretty much by design. So when editors come in and they update a story, or they change a headline, or they add a new photo, those versions or snapshots are then stored in Couchbase. Presto is making use of Geronimo via command API, and actually that's somewhere where we've explored Nickel, which Chris will talk about later. But as you can see, now that we've sort of completed this overhaul, there's no more core AMI at that point, and there's no more the core RSP mobile services, UX services. So this has been about a year in transition, still finalizing details, but that's where we've gone to, and I'll let Chris take over for the remainder.
Hi, so what I wanted to talk about was our larger vision for the architecture at Gannett. Push publishing, as we've called it, which is the thing that Alon covered, is an integral part of the overall architecture because we're largely a news organization. But we actually do some other things that Couchbase actually let us migrate architectures or modernize architectures and fits into what we're referring to as our hybrid cloud strategy. And the whole idea there is, as Alon actually alluded to it a couple times, we want to be able to scale to meet our user needs. There are cases where we actually need to be able to expand out into public clouds, or even just be able to shift around our private clouds. And that combination of like using Amazon and Google and Azure and OpenStack allows us to be able to change the landscape of our applications pretty seamlessly. And doing that with something like a SQL Server, where you'd have to go through and patch servers and stuff like that, is very difficult. So Couchbase itself has been an integral part of that whole strategy, because we can kind of lift and shift it in XDCR into different ones to make sure that we have new clusters available pretty quickly in whatever availability zone we needed to have data available in. So as part of that, we had to introduce some additional tools. Most of them have to do with managing the cloud spaces. So there's Scalar, and I know the Scalar guys were around also today if you guys got a chance to talk to them. Really what they gave us is the ability to manage all our clouds in sort of a seamless way. Developers and operations folks who are working with the clouds, they just kind of go into an interface and sort of point to where they want the application to live in terms of what regions and things like that we have things available in. And the other thing that's a big part of that is Chef. Chef gives us the ability to work with servers in sort of a consistent way. It gives us configuration management, and it hooks in nicely to our continuous delivery pipelines for our applications, so that when we spin up a Linux machine, regardless of where we spin up the Linux machine, it's always exactly the same for a type of application. So we have Node.js applications, we have Python applications, and the whole idea is we use at the Linux level and at the individual levels for both Python and for Node.js, we use Chef to basically give us the same kind of looking boxes everywhere. And as part of this transition, we've introduced some tools like RabbitMQ and Solar, along with Couchbase and Node.js, to move away from things that we used to do in SQL Server. And SQL Server kind of allowed us at a point to do things like searches and other things like that in sort of one unit, and anyone who's used SQL Server is kind of accustomed to that. We've migrated a lot of that search functionality out into Solar, and some of the things that we did with replication even were done through SQL Server have been moved into places like RabbitMQ. RabbitMQ, because it has fan-out functionality, allows us to actually fan out across regions. So as we do our publishing pipelines in particular, when we publish a message to the first RabbitMQ cluster that Alon mentioned earlier, that RabbitMQ cluster can fan out across regions, and therefore we're not doing replication with the renditions, the 5+ renditions. We're doing it with the source content that's being published out of the system. And that's actually a pretty powerful tool, because it sort of reduces our replication load by down to about a fifth of what it would be if we were doing it through XDCR. But there are still some examples where we want to be able to fail over within a region where XDCR has actually been very important to our strategy. So in that context, we actually have looked at, as part of that, as you can kind of see, a lot of those tools that are listed there don't need to run on Windows. And that's actually another benefit that we've gotten out of it, is we've been able to transition away from a lot of our Windows servers in general into this Linux space, where one, servers are cheaper, and two, they're often smaller. They don't require the same amount of resources to do the same things. They're also easier just kind of to automate. We've kind of found, as we've gone through and started to spin up boxes, that it's just generally easier to just stand up a Linux box and a Windows box for a variety of reasons. As part of this, we were trying to get into the mode of thinking, let's not do caching for anything. So our goal, in a sense, is to get down to the place where we're not doing Akamai caching, we're not doing mastery caching, we're not using Varnish, no cache tools whatsoever, if we can at all avoid it, and just support all of our user workflows directly back at our edge storage, which in this case would be something like a Couchbase or a Solar. So let's talk about how we chose Couchbase. As I mentioned, there was sort of this thought about moving away from caching, and as we kind of described it when we first started talking about it, we referred to it as push cache research, if you will. And really what that means is we were looking to start, instead of having Akamai pull in URLs and content from those sources, we would say, let's take the data that we want and push it closer to the edge, and that would act as our cache for the data. And as part of that, we looked at multiple NoSQL options. We looked at React, we looked at Couchbase, we looked at MongoDB and Cassandra. But as we went through the research and looked at what type of data we had, some of our scaling concerns and some other things, we started to realize that key value with document storage was basically where we wanted to end up. And we really liked the architecture of Couchbase. And a lot of what we liked boiled down to things like the memory first approach, eventually the things inclusive of things like nickel, as well as some of the things that you get out of other offerings, but basically the XCCR type of thing. They had like sort of a very well documented, well thought out approach to moving into replication, that they had like sort of the TCP, closer to the wire protocol thing that they described to us that was a better sounding offering than what we heard from other folks that had cross data center replication implementations. So let's talk about sort of a telling load test we ran. We looked at our publishing pipeline and sort of our read workflows within that pipeline and came up with some numbers that were basically around 500 writes per second and about 3,000 reads per second, and sort of on average for our day within the publishing system. We were able to actually kind of ratchet up some load tests and get them up to about 10,000 writes per second and about 30,000 reads per second. This was done inclusive of spikes up to 300,000 reads, which is actually sort of something that indicates what we would normally get for things like storms and elections and other types of breaking news. And it was actually, we were able to sustain that with a cluster that had 8 nodes that were R3 extra larges running in Amazon, about 32 CPUs, and about 172 gigs of memory allocated. So, with that load test, we even did stuff like rebalancing and other activities that you would expect to be able to do during a normal Couchbase run, and everything went pretty well. We didn't see a lot of latency within the applications that were calling it. We didn't really see any specific, any bad failures, if you will. All the failures that we saw were kind of expected failures. So it behaved swimmingly, honestly. It was even better than we anticipated once we kind of cranked it up to 10,000 writes per second. So as we sort of looked at implementing Couchbase throughout our ecosystem, one of the places that we realized was sort of a low-hanging fruit for us to prove out our model was memcache. And it goes kind of into that whole moving away from the pull cache mentality, if you will. But still, there's some places where memcache actually has some useful benefits for us. A lot of that goes into things like application settings and things like that we use within our space. But the whole idea was we could actually leverage the Couchbase memcache style buckets that don't persist to disk and replace that server setup that we had with the 5 nodes with Couchbase, a Couchbase cluster that's basically the same size. It went from 5 nodes to 5 nodes. But what we gained as a result was we gained the ability to give each application its own key space, which was actually a really huge problem for us at one point, where applications, as an example, a lot of our applications all live sort of in the same server space, and they may say everything is a user. So the starting a key with the word user was bad because you may end up colliding with another application that has a user. So as a result, when we start to put applications in their own buckets, which is a thing you would do naturally in Couchbase, they stop colliding just naturally because they're in different buckets now. The other thing that actually happened as a result of that is we were able to give people things like passwords for their buckets, so that when they're working with the memcache buckets, they can actually kind of lock down their space. So they're not only is there not like a key collision, but there's not even like a good chance of an application that's misconfiguring itself and pointing at it without the right passwords. And effectively what we were able to do also potentially is give us the ability, this is sort of part of our longer term vision as well, is those applications will more naturally move into this new cloud space because we're using Couchbase again. So moving our memcache setup was going to be a little bit harder just because of the way we baked it in on-prem. Our Couchbase stuff from the start was designed to work with Chef and things like that to work inside of AWS.
And how many buckets have you been able to manage?
How many have we switched over?
Yeah.
We switched over all the ones we had. I believe we had something like 19.
So you have 19 buckets running on the server?
So basically we had 19 applications.
Oh, okay.
The number of buckets, I'm not exactly sure how they divide up because some of the applications are like microservices, so they belong to the same space.
Okay.
I know for a fact that there's like an example where 4 applications share one memcache bucket because they're all part of the same application space. But in essence, that application key space was represented by one bucket, and so that I don't think there's really that many spaces. I think there's probably only like 6 or 7, but we were able to move 19 applications. Does that answer your question?
Yeah.
Okay, good. So let's talk about some of the other opportunities in terms of replacement that were lower hanging fruit for us. We were starting to introduce, this is for, you mentioned Presto, and in a couple of slides before, that CMS was actually starting to move into the mean stack. So they had, outside of this cloud strategy thing, they were looking to modernize their application stack within that CMS, and they were looking to transition into Node.js as their primary technology stack, so they looked at the mean stack. The mean stack, for those who are not aware, is basically the combination of MongoDB, Express.js, Angular, and Node.js. This is what the acronym effectively stands for. When they introduced the mean stack, naturally everything they were doing was back-ended by Mongo, so they were pushing a lot of data for the application of what is called Presto itself into that space. What we started to talk to them about was transitioning the stuff that's in Mongo into Couchbase as part of sort of unifying and consolidating some of sort of the operational workload, if you will, within that space, because there's challenges with using Mongo in that space. And most of it has to do with being able to be highly available. So Presto should run in every region that we have inside of the cloud. So if we're running it in the equivalent of like 4 AZs in Amazon, for those of you who are familiar with the concept of running it sort of in 4 places, we want to be able to run it the exact same way everywhere without any kind of weird restrictions, and everything should replicate between the regions cleanly. That was a hard thing to do with Mongo, the MongoDB setup that we had, especially when it came into things like user sessions and stuff like that. It was a little bit of a challenge. So we started to move those things, the application settings for Presto, as well as a module that's referred to as workflow planning, which basically is sort of like an automation workflow tool. It's a visualization tool for editorial workflows out of MongoDB into Couchbase. So the end result will be that we'll have literally all the things that were part of the M in mean stack inside of a Couchbase stack. We're not moving it to another kind of like Keen stack. I know there's a Keen stack concept that exists, but we're not moving it into a Keen stack. We're just moving it into Couchbase using calls directly to the API. Another example of where we're actually starting to move things away from their existing backends that was a little bit more of a low-hanging fruit than the publishing system, which is a little bit larger, is UGC. UGC, just to explain the acronym, is user-generated content. And what I'm going to do is I'm going to open up, hopefully I'm going to just be able to open this up right in context. UGC is actually an interesting part of some of our products. When you go to places like USA Today, USA Today has this thing called Your Take, where you can actually upload content and sort of interact with things that are related to ongoing trending tags and things like that in context of a UI. I'm hoping it will come up any second now. See if I can. I don't know what's going on with the Wi-Fi. I know. Might be the Wi-Fi.
Yeah, it's been kind of up and down today.
All right, well, I'll sort of explain to you what it is from a high level. The idea is when you're inside of USA Today or some other site within our system, what there's this UI where you can kind of go in and say, hey, you know, I have an adorable dog, or, you know, you really like the storm that you see outside of your apartment, and you want to take pictures of it and send it to us and share with us what that looks like for you. And so the idea is you go in and you take those pictures, you post them to this Your Take site with some metadata to explain what the picture is. It goes into a Couchbase server, which is surfaced as sort of an unmoderated content staging area, if you will. And on the other side, there's an application that we refer to as Tempo, where there are folks that will moderate that content and say, yeah, this is okay to show back in Your Take. So whenever you upload something to Your Take, it doesn't immediately show up, but there's a moderation process just to make sure no one's doing anything terrible with the pictures. But that being said, you know, that whole thing actually is all driven through one Couchbase cluster that's shared between the two applications. One thing posts to the Couchbase, and one thing reads out of it, and then posts back, and that's basically how the whole thing works. It originally was backed by a Postgres cluster that we ran out in Amazon. That's now been transitioned to a Couchbase server instead. That has also sort of made the switch from sort of a Postgres SQL style setup to a key value setup. It uses it purely as key value. It doesn't use any. It actually uses a little bit like views, but it doesn't use any nickel or anything like that at the moment. So The thing I'll end with is just sort of where we're looking to introduce nickel into this architecture and sort of in a larger sense. The biggest place we're looking to introduce nickel is in the Geronimo system that Alon alluded to earlier. So just as a reminder, people go into Presto, they would edit stories and things like that. It would go through this API referred to as Geronimo, which would generate events and it would save them into Couchbase. Sort of the challenge we've had with that is those events all apply to things like aggregates and users and things like that. What we do as a result is we create a lot of these interesting like application tricks, mostly things like documents that describe other documents, to roll up these things into shared spaces. So as an example, if you're editing an image, right, we want to know all the changes that were made to that image. So what we do is we create a document for the image, and it actually points to all of the individual changes made to that image. The better sort of approach we would like to use with that, which basically nickel affords us, is the ability just to query for all the things that kind of start with the same key prefix. Is sort of where we would like to end up. And that's sort of what I mean by we're trying to reduce our reliance on manifest, generally what we refer to them as. Similarly speaking, there are some places where we use views in sort of the same way. We've kind of rolled up things into a view space, saying like this is the most popular things for the last 10 days or something else like that. We can probably just leverage nickel instead of using the views, and also introduce things like global secondary indexes to improve some of the performance as well. And there's some other simple lookups we do in Solar right now that we could also leverage nickel for instead of using Solar. So as an example, we would say, give me all the assets that are an image that were posted in the last 10 days. Those kind of things we can actually use nickel for instead of using Solar, and use Solar for mostly the things that we want it for, things like text searches and things like that, which we wouldn't necessarily do inside of nickel. And then the other reason for introducing nickel is just for a lot of these things that developers doing it from a day-to-day basis, where they're interested in working with the Couchbase buckets, just to get some data to play around with for some application they're writing or something else like that. And as a result, right now what they have to do is they kind of have to go into Solar or go into SQL Server, identify the things they want to play around with, and then look them up in Couchbase. What we're saying is they'd be able to just go right into Couchbase, write a nickel query, pull stuff back that they want to use as part of their test application, and just leverage it directly that way. So that's a lot of that stuff is kind of tying back into this, reducing the cognitive load for developers. There are also some operations folks as well that are interested in the same exact concept, where they're looking at the performance of the databases and stuff like Couchbase clusters and things like that, and are trying to understand what's going on. So it'd be nice for them to be able to run a nickel query and say, hey, what assets were recently produced that may have caused something to slow down or misbehave or whatever. And that would also be part of this concept of being able to introduce nickel as a way for them to not have to look up things in roundabout ways to then go back into Couchbase. Sure.
So in the Solar thing, Solar, you put in Solar so that you can speed up your search and help your system performance. And now you want to migrate that from Solar to the Couchbase.
So Solar is faster than SQL Server for full text search for example, right? And it should be faster than Couchbase probably too as well, because that's really what Solar does well, is full text searches, right? That's really what it does. But for looking for things by their properties, like saying it's by its asset type or something like that, I don't imagine there's going to be a huge difference between Solar and Couchbase, to say it that way. So
Key value thing.
exactly, something like that.
Right away.
Right. Yeah,
Right,
exactly.
A lot of queries that we do in Solar now we're trying to get results back that are limited by the asset type. So as Chris mentioned, I want to see just images. I want to see just the recent stories. That could be easily supplemented by nickel.
Right. So actually, that was kind of a good segue into the questions. Just, that was all I had. Did you guys have any questions?
Yes, I think in your project you migrated from relational to Couch and also from Mongo to Couch, right? What was the effort involved in migrating the data?
The data?
Yeah.
That's an interesting question. So I would say that in a general sense, what we've sort of done is when we look at what the APIs are returning, they are good starting points for what we'd want to have in Couchbase. So when you look at the API responses, if you will, they sort of act as schemas for the JSON you may want to store as a document. So the way, like, conceptually the consumers perceive the data, and as well, like, you as developers will think as the data that's inside of the database. Even though technically underneath it, it's broken out into more pieces than that. So a simple way to sort of start is to say, okay, what is the code that would be used to generate this for the API response? And then kind of start there with that as your schema, and then figure out what other tweaks you may want to make to optimize it for use in Couchbase. But that's sort of what we do. Is even programmatically, the applications will actually use the exact same serializers and things like that to pull the things into POCOs, and then from there they will go and figure out how to push them across to go into Couchbase.
What were kind of the reasons for wanting to get off of MongoDB? I'm dealing with a lot of folks who want to switch everything over to Meteor, so I have to have some
Gotcha.
for Mongo.
The biggest reason for it had to do with scale out, really, is the biggest thing. So I find that generally speaking, Mongo is really popular with developers because there's all this stuff that is built around it. And it is very easy to integrate with. But the problem is once you have it in production and you want to run it like scaled out, it's kind of hard, right? There's like the Mongo S, Mongo D kind of paradigm. And once you start pairing those things together to start doing replication and working across data centers with failovers and everything's active, for example, it becomes a lot harder to do than working with like a Couchbase, for sure. Sorry, you had a question.
So you used to have the SQL Server earlier, and now you have Couchbase, right? So is
Right.
most of your data structured, or you have some unstructured as well?
That's a fascinating question. So in a sense, I would say it's semi-structured is probably the best answer to your question. There are a lot of places where we kind of know what an asset looks like. There are some places where, especially since we integrate with other third parties, where we don't know what things look like. So especially if we're working with say like an AP content feed or something like that, they may not agree with us on what's inside of an article or what's inside of an image. And because of that, sometimes there's actually this thing where we have to retain additional metadata that we don't care about in our system. But we need to have it there for a variety of reasons because it's the way AP would structure it or use it on the other side. So there's a bit of structure on our end that ends up bleeding over into we integrate with third parties, so we end up having to accommodate the other additional metadata
Which
points.
is why we have several documents per asset,
Right.
sometimes in Couchbase.
Right.
But would you recommend Couchbase for structured data as well, or it will be just a complement?
Actually, I would. So that actually gets more into, so the schema enforcement part then ends up living in your code, right? And that's a little bit different than what you'd have in SQL Server. So what ends up happening, which is nice, is as you're evolving your application, the schema lives with your application, and as your application evolves, naturally your schema evolves. You don't have to do secondary deployments of the database. You don't have to turn off anything, which is also really nice. And then you've moved over to your new schema just by updating your code, which I actually really like, personally.
But how about the DMLs? Like read, I understand it may be faster, but how does it handle the DMLs in the Couchbase?
The DMLs?
Updates, insert, deletes, as opposed to a traditional relational database.
It's in terms of like adjustments to the DMLs, you mean?
No, how robust or how mature it is.
So if you're talking about just like purely like how well does it handle writes, it handles writes quite well. It won't handle the shifts part is actually part of your application code. That's sort of why I was asking the question. I wasn't really sure if you meant like how does it handle the shifts in the schema. The shifts in the schema belongs to your application. Okay.
Because generally what I've heard is like NoSQL databases are good for reads, but may not be so good for the writes.
I would actually say
I
that's.
just wanted to get your side of it.
Sure, I would actually probably say that because I've been working with NoSQL for a while, and that was definitely more true when I start looking at things like Cassandra. I've used Cassandra before. That's definitely more true in that space. I found that Couchbase is not the same in that way. It handles writes pretty well. There is, the one caveat, if you will, that has to do with the way Couchbase works, is that it's a CP system. So in a sense, what you have to do is sort of accommodate the fact that when clusters start to fail, you have to sort of queue your writes up to make sure that they eventually end up back in the database. But that's really the only nuance that I've ever really encountered with the writes, if you will.
Most of your transaction patterns should be write only or append only, right? So it's basically contents. Do you update those contents? Why you didn't consider some other solutions? I mean, what is the reason behind to?
I think your comment was sort of more of a SQL style comment, honestly. To tell you the truth, updates are not that bad in this context because you're doing it against a key, so it's not that difficult.
But in your case, do you have a lot of
Yes, a ton of updates. Yeah, so in reality, a lot of it's driven by what people are doing to the asset. And if you think about it this way, people change headlines, people change like the body of an article. There's editorial workflows, or editors are constantly sort of changing and moving things within the body of the article. Those will all happen within Couchbase.
How did you migrate the data?
So in essence, the push publishing mechanism that Alon was describing earlier actually acts as a natural mechanism to migrate the data. So what it does is effectively it pulls stuff out of SQL Server and it pushes it. It's doing that for a different reason, but it also ends up migrating the data at the same time. It's sort of double benefits there, if you will. Which basically just means construct it into the JSON payloads we want, send it across. And that's the natural way we move things over, if you will.
How will you maintain JSON schema consistency across all your document instances in Couchbase over time?
We actually don't have that many, which is one of the things that I don't know if you, there's not like a ton of them. There's probably like 5 at the moment. In terms of maintaining consistency across the different instances,
You add 4 or 5 new attributes, for instance, right?
Sure.
Maybe nested 4 or 5 levels down to represent some new capability.
Right.
And you've got 100,000 historical documents already in your database.
Oh, okay. So you're kind of asking about like sort of compatibility with documents already written. Okay, that's fair. So with documents that are already written, generally speaking, what we do is we have one of 2 approaches. Either we re-push the assets from their origin space, because we're saying that they need to be there for whatever reason. And it's sort of like, we call it a reindex, if you will. The same problem we have kind of with Solar as well, right? Solar actually has sort of the same kind of caveat. When you introduce new things into the schema, you have to re-index the stuff from the original store. If you're talking about from the origin, though, like say the Couchbase for authoring, that actually there's no schema problem there because it's already naturally decomposed by event. So if you add a new thing into the schema and add a new event for it, it just falls into place. It just, because everything is immutable. It's an immutable structure. It doesn't actually have a concept of like you're modifying an object that already exists, to put it that way. So on the presentation side, we had to sort of re-push from the origin, but from the authoring side, it's sort of a schemaless thing that just is based off of the events that are generated by the system.
So you reassemble it every time.
Yeah, right. So in essence, the authoring system is a little more fluid, and it's done that way partially because we want to have a clean versioning within those documents. So it's basically like a tree of versions that come out of the asset, and that also lets us do other things like conflict resolution and other things like that. It's a lot like how Google Docs works, if you will. But it gives us a natural sort of re-index point back from the origin that we can run whenever we need to. Any other questions?